Today's over 7.6 called rational exponents. So today we're going to be kind of combining exponent properties with the radical things that we've been doing. Because in order to write a radical, you can also use rational exponents. And so we're going to learn today what that looks like. Remember, rational just means fraction. So we can write really an exponent that looks like a fraction. So what that looks like is this. 8 to the 1/3 power would be the cube root of 8. Whatever the denominator is in an exponent, that is what root you're taking. And then using your calculator or your whatever you've memorized, the cube root of 8 is equal to 2. So for any real number b and for any positive integer n, that b to the 1/n is going to be the nth root of b. Except when b is less than 0 and n is even. So if it's negative and you're taking even, you can't do that. But for the most part, whatever your denominator is, that's what root we're taking. So if we look at a few examples here, they just want us to write the following in radical form. So what we're going to do is we're going to say this is 1/4. So because it's the 4, we're taking the 4th root of a. Now I can't do anything with it, but they just want us to rewrite that using exponent form, or radical form. So then 1/5 is going to be the 5th root of x. And 7 to the 1/4 would be the 4th root of 7. Now because it's a number, we could actually figure that out, but they don't ask us to do that. So again, continuing on, they want us to write each of these in exponential form. So if we're writing these, if we're going backwards, if I'm taking the cube root of something, that's just going to be y to the 1/3 power. Same thing with the 6th root of x. Whatever this is, stays our base, and it's 1/, whatever that index is, whatever the root is. Alright, so now they want us to actually evaluate these things. So now we're throwing in a few different exponent properties here. So if we have 16 to the negative 1/4 power, that first off, the negative tells me I want to go 1/16 to the 1/4 power. So nothing with the fraction changes the fact that if it's a negative, you're going to flip that and put it in the denominator. So now I have 1/16 to the 1/4 power. Well, that 1/4 tells me I want to take the 4th root of 16. What is the 4th root of 16? We're looking for something that multiplies by itself 4 times to get 16, and that's going to be 2. So this will finish off being 1/2. Now what happens when we have numbers besides 1 in the numerator here? Well, what that tells us is we're looking at the 5th root, because that's our denominator, of 243 cubed. Whatever that is still an exponent. It's telling you what power you're raising it to. Now you can do this a couple of different ways. We could say 243 cube it and then take the 5th root, or the same thing would be if I take the 5th root of 243 and then whatever that answer is, I cube it. That's the easier way to do it because you're taking the 5th root and making this small, and then you can cube it. So we want to figure out what the 5th root of 243 is going to be. So when we look at that and figure that out, turns out to be 3. So when we have 3 cubed, which is going to be just 27. Now, if you would have done 243 to the cube and then taken the 5th root of that, you would still end up with 27. So it's really up to you whichever way you'd like to do it, but sometimes taking the root first is easier, and then you can just cube whatever you get left. Alright, and that kind of leads us into this next example. Or this next bit of information where they're telling us anything in the numerator that's bigger than 1 just becomes your exponent. So for any non-zero real number b and any integers m and n, you're taking the nth root of b to the m or the nth root of b and then raising it to the m power. So here again we go back to our 8 example, except this time we have it raised to the 2/3 power. 8 to the 2/3 power is going to be the cube root of 8 squared, or the cube root of 8 and then square it. The cube root of 8, as we said before, was 2. 2 squared is 4. So looking at some additional examples here. Remember, when we're multiplying, what do we do with our bases? When you add, or what do we do with our exponents? When you are multiplying like bases, you add the exponents, remember. So this is going to be 8x to the 1 plus 7, which is 8/5. So then simplifying this, if I rewrite this as the 5th root of x to the 8th power. Remember, I can rewrite this as the 5th root of x to the 5th times x to the 3rd. Then we'd be adding those. So the book may leave it this way, or it might take it the whole way down and say, okay, well that 5th root of x to the 5th is just x, and we're left with the 5th root of x cubed. So either way, I'm guessing the book is looking for this first one. That would be okay with me if I say to simplify it, but the book also might give you this one, because you can just rewrite that a little bit. On the other side, we have r to the negative 3/4. That's just, the negative tells me that's r to the 3/4 in the denominator. And that's about all you can do with that one, because the denominator is bigger than the numerator. Alright, so let's look at some other things using more exponent properties. Again, these are all things that we discussed way back at the beginning of chapter 6, which seems like it's been a long time ago. When we look at these, the 8th root of 81, let's see what that's going to give us. The 8th root of 81 is a decimal. So what we want to do, since that's not going to give us a nice number, neither is the 6th root of 3, we can rewrite this so that it is a value of 3. So I'm going to keep it as the 8th root of 3 to the, it's going to be 3 to the 4th power. All over, and this is going to be 3, I'm just going to write that now as 3 to the 1/6 power. So if I rewrite this whole thing turns into 3 to the 4/8 or 1/2 power, all over 3 to the 1/6 power. Now we're not done yet, because I have 3's here, so what can I do here? I can subtract the exponents. 1/2 or 3/6 minus 1/6 gives us 3 and 2/6, or 3 and 1/3, which would be the cube root of 3. Again, looking at this one, if I rewrite 9 as 3 squared, the only thing that we can really do here is say this is 3 squared times z squared. I'm going to rewrite that. That's going to be 3 to the 2/4 and z to the 2/4, which ends up being 3 to the 1/2 and z to the 1/2, or just the square root of 3z. It reduces itself. Over here, what we're going to do is we're going to multiply again by the conjugate. So even though it's with the 1/2, it's going to be m to the 1/2 minus 1 over m to the 1/2 minus 1. So when I distribute this, this ends up being the same thing. So we have m to the 1/2 times m to the 1/2. We add exponents, it gives us just m. Then we have minus m to the 1/2, minus m to the 1/2, and then plus 1. All over, again, m to the 1/2 times m to the 1/2 is just m. These are going to cancel because you have plus m to the 1/2 minus m to the 1/2, and then we'll just have minus 1. So in the middle here, it turns into m minus 2m to the 1/2 plus 1 all over m minus 1. And there are ways I'm sure the book would have you rewrite those. I'm not worried about those for now. All we did there is we eliminated the fractional exponent, or that square root really, out of the denominator, which is the important part there. That's it. We have 17 through 31 odds on page 420, and 35 to 49 odd. So really it's just all the odds, we're skipping 33, from 17 to 49. So this is a large use of exponent properties. So if you need to refresh those, they're kind of scattered throughout the first part of chapter 6.